Hello students, welcome to this video. I am Abhishek and today we are going to talk about measurements. Many a times you will find this chapter by the name of units and measurements. So we are going to talk about units also in this chapter. So we'll start with something called physical quantities. We'll learn about that. There are two types of physical quantities. We'll learn that. And correspondingly, we have units, so-called base units corresponding to base physical quantities or fundamental physical quantity, and the other one is derived physical quantities, and correspondingly we will learn about something called derived units. Okay, so and after that we'll also learn about how to convert one system of units into another, like 1 inch into centimeters. So there are some conversion factors which we will need to keep in mind, and we would be able to do a lot of things. You can also convert 1 meters per second into kilometers per hour. So it's gonna be really interesting. So let us start. Measurement is a integral part of our life. The moment you get out of your bed every morning, you go to a washroom to brush your teeth, and you take up the toothpaste tube, and approximately you try to measure that how much you need for brushing your teeth, and more or less it's nearly the same, approximately the same every morning, right? But not exactly same thing happens when you mix sugar in your milk or tea, coffee, anything in the kitchen, and you use a tablespoon for that, and that is also a measurement. Similarly, in daily life, we get to have a lot of things like that where we require to measure something, right? So, there are some very accurate measurements also. As I told you, we are doing just approximate measurement. It doesn't matter even if 1 gram extra sugar is there or 1 gram is lesser than what we were expecting. Okay, that doesn't matter. Similarly, you have, like, even if you take a small uh, like amount of toothpaste, it is coming extra in your brush, that doesn't make a difference. So but when we talk about scientific measurements where, let's say, some reaction or something is going to be conducted in labs, you require a very accurate measurement. So that's why it is very important to understand measurement. I would give you a simple example where you go to supermarket to buy potatoes, and over there, how the accuracy matters, I'm going to tell you. It happens quite a time. It might not be exactly, let's say you are purchasing 1 kilogram of potatoes, so you are expecting 1000 grams, and he's also expecting to give you 1000 grams by measuring it, let's say, or any general store you have been to where he is using a physical balance to measure it. But sometimes, even if it is like 120 grams, it doesn't make a difference to him. He is happily giving you that packet with 120 grams of potatoes. But when you go to a jeweler shop to buy 10 gram of gold and ask him, please give me 11, let it be little higher, this would be a big loss to him. So the value of things which you are measuring will decide how accurate your measurement should be, isn't it? So with that, let us learn what is physical quantity. So physical quantity is basically something which we can measure, anything which we can measure, physical quantity, okay, in simple terms, okay. And if we define it, it is a property of system or any body or material which can be quantified by measurement. For example, if you have got any body, this body could have some mass. Let's say there is a body which is kept on table. So this body could have mass, this body could have some volume, right? All these are measurable properties. So physical quantity is that property of any system or a body or a material which can be quantified by measurement. So we can measure it, right? We can measure this one also. You can measure length, width, height, okay, all those things. You can also measure temperature of this body. So a lot of interesting things can come up over here, right? So all these are known as physical quantities. So physical quantity may have a unit also, okay, many a times it has, sometimes it may not. One such example is relative density. Okay, it doesn't have any unit, it's just a ratio. Relative density I'm talking about, you will learn about it later on. Relative density, which is defined as density of any substance upon density of water. Okay, so density cancels out each other, it gives you a number finally. So a lot of interesting things like that we are going to learn in this chapter. So physical quantity is something which you can measure in simple terms, and it should have possibly a unit. It can be expressed in terms of some unit, like we express mass in kilograms, volume in meter cubes. It can be centimeter cubes also. So there are different systems of unit that we will learn. Then your length, width, temperature, okay, a lot of such things can be measured, right? So these properties of this particular body are known as physical quantities. So that's the basic idea. Now there are two kinds of physical quantities. One is your fundamental physical quantity. I'm switching to the next page. Fundamental physical quantities and derived. Okay, there are seven fundamental physical quantity. Fundamental means there is nothing more simpler than that. Okay, there are seven such physical quantities, and derived are those which are made out of fundamental physical quantities. I'll give you those examples also. But let me give you this complete set of seven fundamental physical quantities. Okay, we have got mass, we have got length, we have got time, we have got temperature. With time, you would be able to remember all these seven. We have electric current, then the electric current. Then there is something called amount of substance. Then we have luminous intensity. Okay, so these are seven fundamental physical quantities. We can make up any new quantity using these seven or some of these seven, and that will be known as derived physical quantity. For example, speed. You must be knowing speed is defined as distance upon time. So you can see it is using one quantity, that is length. Distance will be measured. So basically you are measuring the length of that path, and time. So it's basically using two of your basic quantities or fundamental quantities. That's why we call it derived physical quantity. Okay. Similarly, we can have any other derived quantity like your volume, area. They are using length into length and length into length into length. Okay, so basically length into width into height. Volume LBH. Area is your L into B, base area, let's say, of any cuboidal body, like the previous body we can talk about. Okay, so they are using two times the length. So length and length is being multiplied. So it's giving you a new quantity, so called the area. It will have a new unit which will defined using this formula. Okay, like the area we know, the formula is meter square. How does it come? Length into width. So length has got a unit of meters and width has got a unit of meters again. So meter multiplied by meter becomes meter square. Similarly, this guy becomes meter cube and the first guy was meters per second. Okay, it's really great. So we are going to talk about those basic units which are related and then you can understand it better. So mass has got a unit of kilograms. That's the standard SI unit. There is something called SI unit. SI is an international organization which decides all these units. Okay. So SI units of fundamental quantities I'll write down. For mass, it is kilograms, not grams. Length, meters. Time, seconds. Then electric current, it's measured in amperes. Symbols are also very important. Okay, the name is ampere. We call it ampere based on a scientist's name. Then we have temperature. The SI unit is Kelvin, although we have Fahrenheit, degree Celsius, but the SI unit is Kelvin. Okay. Then the last two might not be very useful at this point of time, but it would be quite useful at a later stage. And their units are mole. We call it MOLE, mole. Okay, that's the name, and MOL is the symbol. And luminous intensity. It's candela, CD. We represent by CD, and it's candela. Okay, so thank you.